what about a monster the size of the Subaru Quasar? Recent discoveries about the rapid rise of these giant black holes have led theorists to rethink their view of cosmic history. Back in 1995, the Hubble Space Telescope was enlisted to begin filling in the details of that history. Astronomers selected tiny regions in the sky between the stars, looking north, south, and south again. For days at a time, they focused Hubble's gaze on these tiny patches of sky to examine the deepest regions of the universe. These deep field images offer incredibly clear views of the cosmos in its infancy. What drew astronomers' attention were the tiniest galaxies, covering only a few pixels on Hubble's detector. Most of them do not have the grand spiral or elliptical shapes of the large galaxies we see closer to us today. Instead, they are irregular, scrappy collections of stars. The Hubble Deep Field confirmed the idea that the universe must have evolved in a series of building blocks, with small galaxies gradually merging and assembling into larger ones. You can see evidence of this pattern simply by looking out into the sky. Many galaxies are gyrating around one another. Some are crashing together. Others ripping each other apart. Gravity calls the tune as these galaxies draw together, exchange stars and gas, and, over time, merge to form larger composite galaxies. Lately, though, this picture of a universe taking shape from the ground up has gotten a lot more complicated. The quick appearance of giant black holes and galaxies in the early universe is at odds with the gradual way matter builds up in most galaxies. They likely had their beginnings in the first generations of stars that literally burst onto the cosmic scene in a time of incredible turbulence. These stars were born in knots that developed in the diffuse gas of the early universe. Gravity drew these knots together. In the most dense regions, the stars were born in waves. Many of them gave birth to black holes. Within a relatively short time by cosmic standards, the earliest black holes swallowed more and more matter, growing to monumental proportions, becoming quasars. These quasars, in turn, were fed by the collapse of matter on a much larger scale. This computer simulation recreates a region in the early universe that measured over 100 million light-years on a side. It shows what took place in the first 1 billion years of cosmic history. This virtual universe is set in motion by equations describing the properties of gas, the energy released in starbirth, and the outward motion of space and time. The result, an intricate cosmic web, with gravity drawing matter into filaments and knots, as if you were looking down through a vast tangle of interconnected spiderwebs. Inside the most dense regions is where the largest galaxies and black holes grew. Here, circles indicate the appearance of black holes deep in the data. As they bulk up by eating up their surroundings, the circles grow larger. A few, in the largest galaxies, reach ultra-massive proportions, billions of times the mass of our Sun. This is the scene in one of those dense intersections. thousands of galaxies, and gigantic clouds of gas spiral inward. A large galaxy emerges in the center, and at its center, a giant black hole, force-fed by gravity.